I welcome all of you for physics sessions in your PU classes. Say, we start with the enchanting thing in physics. Say, how many sunsets you can see when you are in beach? Literally, one can see two sunsets. Say, two sunsets, and using those two sunsets and the time gap between two sunsets, one can measure radius of the earth. That's a very enchanting and thrilling thing what we want to go for. That's how we start with our first part in physics, where we learn about the measurements. Measurements, what we do. In fact, whenever we do measurements, we need to take, say, this piece of chalk, how many centimeters it is, or how many meters it is, or this paper piece, how much area it covers, or this board, what is the area of this board, or in this room, what is the volume of this room. All those things to be measured in day-to-day life also. That's why in physics also, measurement is a very important part. That's why we start with measurement topic only. And finally, at the end of this topic, we will think of how to calculate the radius of the earth by just knowing the time interval between two sunsets and how it is possible to see two sunsets. You have to guess that. Till the end of this chapter, you can think of that. So now we start with measurement. For any measurement, just now we said, say we measure the length of the piece of chalk in centimeter. What do you mean by centimeter? In fact, it is a standard what we use for saying centimeter, say length unit. That's why a standard of comparison is what we call as the unit. Unit means standard of comparison. What we use, there are many units what we can measure. To list out something, to measure the length, you know, in your high school standards, centimeter is used to measure the length of the card. And then to measure the mass, you know, in day-to-day life, it is kg or gram. And time, as all of you know, it is in seconds. So these are the units what we usually use. But basically, some units are defined individually and independently, and some of them are defined depending on other things. Say which are defined independently, they are called as fundamental units. Fundamental units. And which are obtained from fundamental units are called as derived units. So now, can you guess the definition of fundamental unit? It is the unit which is defined independently. So to explain it, you cannot measure length of the thing. If you take centimeter or meter, the length as one of the fundamental quantity and its unit as fundamental unit, you cannot measure, say, length in terms of mass or second. That's what we mean by fundamental. That means it cannot be obtained in any other form other than this unit. That's what we mean by fundamental or independent. In the same manner, the mass cannot be measured in any other things like centimeter or second. It should be measured only in kg or gram like that. That's what we mean by fundamental. So derived means what? Derived means, say, by making use of these fundamental units, we get the unit of something. Say for example, you know from high school classes, area of, say, rectangle, it is length into breadth. Also here, length is measured in meters, breadth is also measured in meters or in centimeter. Length in centimeter, breadth in centimeter. So once we know the area, the unit of length, area can be measured because length into breadth. So this sort of things are called as derived because they are dependent on fundamental units. In the same manner, another quantity, can you guess? What we use in day-to-day life, that is what I write here. It is volume. You know, volume is volume of a cube or cuboid is length into breadth into height, where all the three things have same units, centimeter, 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 or meter, like that. So volume is also a derived quantity or derived unit. Say next one, we think of what you know, speed. In your high school classes, you know speed. Speed means distance traveled by time taken. That is, say distance by time taken, which amounts to be length by time. Here also, as it clearly tells us, you must know the unit of length, you must know the unit of time. That will help us to get the unit of speed. That's why these are all come under the category of derived units. So in the olden days, the people thought of only three things are sufficient to measure anything in this world. What are those three things? Say to measure length, mass, and time. Only these three things are to be learned to measure so that we can measure anything in this world. But later on, as the civilization developed, there are many things to measure apart from these things, say like temperature. But cannot be measured using length, mass, time. Or say light intensity or luminosity. Light intensity cannot be measured by using these three, like that. That's why there was a need to develop some more fundamental units. Such things were actually standardized in a system, what is called a system of international units, usually known as SI units. In fact, in SI unit, there are 7 fundamental units what we can take to measure anything in this world today. So those 7 quantities what we take in SI system as fundamental are this, say length, there are 7, there are length, mass, time, say temperature, amount of substance, electric current, and then luminous intensity. These are the 7 fundamental quantities what we take in SI system, and each one of them have their own standardized units, and we list out them what are the units of these 7 fundamental quantities what we use in SI system. Say length has meter as the unit and its symbol is M. Mass, the kilogram as the unit and its symbol is kg. Time, second as the unit, the symbol is S. Temperature, Kelvin as the unit and K. Amount of substance, mole as the unit and its symbol is mole, MOL. Electric current is ampere and its symbol is capital A. Luminous intensity is candela, its symbol is CD. So these are the 7 fundamental units what we use in today's world, say throughout the world, and we can measure anything in this world using only these 7 things by making their derived units. So one must remember what are the units, names and the symbols what we use for those fundamental units. And by knowing these things, one can obtain any derived unit what we use later on. But there is one peculiar thing in this world. There are some things what we cannot measure. They are called as non-physical quantities. In fact, there is one non-physical quantity called as loudness. Say, what is subjective? not the objective. Objective means it is same for all. Subjective means one who yes, they can only, their response is different from others' response. That's what we call loudness. So such things are called as, even though they are measured, they are not called as physical quantities. They are subjective, they are dependent on the one who experiences that. Such quantities are also there. We can measure them, but they are not called as physical quantities. Apart from that, almost all the quantities what we measure are all physical quantities. And now in this session what we are supposed to learn is, say, what are the 7 fundamental quantities, their units and their symbols to be learned. With these basic ideas, there's one more question to be tackled. In all those 7 quantities what we listed, can we measure the angle? That is our next question. Again, angle cannot be measured using any one of these 7. That's why SI system introduced one more, say, 2 more units for measurement of the angle. They are called as auxiliary units. One is, say, angle is degree or radian. In fact, what you used to measure in high school as degree, now it is measured in radian. That is for plane angle. And the steradian is for solid angle. We learn what do you mean by plane angle and solid angle. So you learned a lot of mathematics geometry in your high school classes. Can you define the angle? That's a little bit tricky. Now we go for that. Say how to define the angle, or how to define the angle in terms of radians. For that we think of like this: any angle is defined as the ratio of the arc length in the circle, say from A to B, if you imagine this as a circle, and this is the radius. If arc length is S, AB, that is AB length is S, then if this is the angle theta, then theta is defined as, the angle is defined as ratio of arc length to the radius. This is how the angle is defined in, say, SI system, that is supplementary angle unit or auxiliary unit. That is, angle is arc length divided by the radius. And in the same manner, one can define solid angle. But before going to solid angle, we just go for plane angle once again. The plane angle is defined as the ratio of arc length to the radius. But what is solid angle? Say, many of you have, you know that when you go for purchasing of watermelon, say, to check whether it is ripe or not, what they do, usually, if you imagine this as the watermelon, they make a cut on this. And that cut piece is taken out and it is, the fruit is checked for its ripeness. So, here, this shape what we obtain when we cut, we can write that like this. Say, this will help us to define the solid angle. Now with this we start defining solid angle. Solid angle means it is the ratio of area cut on the surface of the sphere, say area cut on the surface of sphere, and if r is the radius of the sphere, then solid angle is defined as, say, omega is defined as area cut divided by square of the radius. So this is the definition for solid angle. Area cut on the sphere surface to the radius square of that sphere is what we call as solid angle, A omega, and it is, this symbol is actually pronounced as omega. And you know, in your high school classes, that symbol is used for resistance O. I conclude this session now.